So now in this example, we have a 30-volt battery, a couple of resistors, 10 ohms and 20 ohms, and a 10 milliohm inductor. The switch has been open for a long time, so that means initially nothing is happening. The switch is closed at t equals 0, and we're asking what is the current through the 20 ohm resistor immediately after the switch is closed. So what happens immediately after the switch is closed? Let's think about what happens in that inductor branch. So the battery wants to put out a current. The current would get to this junction. Some would come down here and some would come down here. The branch that will go down through the inductor has got to be 0 because initially all of the current is 0 because the switch is wide open. You close the switch, current starts to flow, but in the inductor branch, no current will flow because the inductor is initially going to oppose that current. So the current through the inductor is 0 because it opposes the change. That means this acts like an open circuit, so no current here. So this is going to be our equivalent circuit. We can redraw that if we wish, if it helps you see the story of what's going on. So this is like an open circuit. So then the circuit we have left has a 30-volt battery, 10 ohm resistor, 20 ohm resistor. And if we want to find the current in our circuit, here's our current flowing. We know V equals I times R equivalent. Our equivalent is the two resistances added together because they're in series. So 10 ohms plus 20 ohms. So our current then is our potential, 30 volts over 30 ohms to give us 1 amp. So the current through the 20 ohm resistor immediately after the switch is closed is 1 amp. Okay, now part B of this problem says what is the current through the 20 ohm resistor after the switch has been closed for a long time. So our switch is closed and it's been like that for a long time. Long time means we've reached a steady state. Steady state means constant current. Constant current means that for our inductor, so for our inductor right here, the potential across the inductor equals minus L di dt equals 0. So after a long time, we've reached a steady state. The current comes out of the battery, comes along here, gets to a junction. It has two choices, can go here or here. If we come to right here, we have no potential across it. It has no internal resistance. That means this is like a short circuit. We could just as well take that out and replace it by a stretch of wire. So let's redraw that circuit just to see if that can help us get an idea of what's going on here. Well, let's just think about this one tiny bit more. So in this circuit then, no, actually, let's go ahead and redraw it because sometimes these things can be a little bit difficult to visualize. So there's the 10 ohm, there's the 20 ohm, and here's a piece of wire. So now let's ask, which way is the current going to flow when it gets to this junction? So the current comes out of the battery, goes around this way, it hits this junction, it has two choices. It can go to a branch with 0 resistance, or it can go to a branch with some resistance. It's going to go to the one with 0 resistance. So there will be no current at all flow through the 20 ohm resistor because the current will all flow through the open part of the circuit. So the current through our 20 ohm resistor, so I through the 20 ohm resistor equals 0 because the inductor acts like a short circuit and all of the current goes through that branch. You could, of course, if you wanted to, find the current put out by the battery. So this current I right here would be the potential of the battery divided by the only resistor it's in contact with, which is the 10 ohm resistor. So 30 volts over 10 ohms to get 3 amps. But that would not flow through the 20 ohm resistor. Through the 20 ohm resistor, which is what the question asked, that's a zero current. So all of the current goes through the 10 ohm and none through the 20 ohm. Okay, part C of this problem, one more part to go through. Part C says, well, we take our circuit that has been closed for a long time and then we open it up. Then what happens? Okay, so let's think about what's happened after a long time. So after a very long time, so before the switch is opened, before we reopened the switch, we had our 30 volt battery, our 10 ohm resistor, 20 ohm resistor, and our inductor, which act as the short circuit. And what we had in each branch of that circuit was that the current through this branch was 3 amps. Then the current came along right here. The current through this branch was 0, and the current through this branch was 3 amps, because this acted as a short circuit and all of the current went through there. So when we reopen it, when we go to here, what happens then is, let's start with the inductor branch. So as soon as we reopen, we still have a 3 amp current coming through right here, because as soon as it's reopened, the inductor resists change. So immediately after reopening, we still get our 3 amp current here. So the current flows down through here, flows right here, and it gets to a branch in the circuit. What can happen at this branch? Part of the current could go up here, or part could go here. But it can't go through this branch because this is an open circuit, because the switch is open. So immediately after the switch is opened, we still have 3 amps going through here, but as soon as we open the switch, we force the current through the 20 ohm branch. And if it helped you to see it, we could draw that branch again. We could draw this, but we could leave off the open circuit part. So as soon as that's broken, it's like this is not even connected. So the equivalent circuit right after we've reopened the switch looks like this. With a 3 amp current coming around. And then the question doesn't ask, but we could ask about what happened over time. So what would happen over time, we've got an LR circuit, and that current will decay over time. And we've already gone through the equation for how that will decay, and it would decay as the equation I equals I0, e to the minus t over tau. I0 would be the initial current of 3 amps. Tau would be the time constant, which is L over R, which you could calculate if you wanted to, 10 millihenries over 20 ohms. So you could ask questions like in this problem of how long would it take to discharge, or draw a picture of the current as it was discharging. So there are a few other places we could go with this question if we wanted to. Okay, one more example and we'll call it good for today.